be writing a simplest program that is about finding the total resistance, the current, the power, and the voltage of a circuit that has resistors connected in series. And we will be using code blocks, and we will be using the C language. So let us dive in and see. First of all, you write our header file, which is #include and stdio.h, and we write our main function. We open and close the brackets. So, and in here, remember, before you do anything in a program, you open your brackets, so we might as well open ours. And we write, now we have to declare the variables we'll be using. So the first variable we'll be using will be number of resistors, because we're actually creating a program that will be flexible, meaning it will be used by everyone and it won't be used by only us who have created the program. So we'll require the user to be the one who enters the number of resistors, the value of resistors, and the value of voltage. So the first thing we do is saying int number of resistors. That's our very first thing we do. And secondly, we say float. We are using the float, and we say float voltage. And comma. Why we're using float? Because the voltage could be a decimal number, and this int number of resistors, the number of resistors, meaning the number of things cannot be in decimal, so that's why we are using the integer, because we're expecting an integer number. So now we're saying float voltage and say total resistance, and we say total resistance equal to 0. Why are we saying equal to 0? We're actually initializing that total resistance to 0, saying that before the addition of any resistor in there, we had a 0 resistance. So that's why we are actually writing equal to 0. And after that, we say current, because our current too will be a variable we'll be using, and we say power. Why power? Because we'll be using power too. And after that, we go and we have to tell the user to do something, so we'll be using the printf function. Now we have to tell the user what to do, so we'll actually say enter the number of resistors. So we'll say enter the number of resistors. We're now telling the user on what to do. Enter the number of resistors. So this is how we're gonna do it. Don't forget the semicolon in here. And after that, we'll be using our scanf function. What is scanf function used for? Scanf function is basically used to read information from the keyboard. So we'd say %g and say comma, and we say and. We're now assigning that value I've entered in this line in here, which is this printf enter the number of resistors, to this int number of resistors. So we say and num resistors. We have to write it exactly how we wrote it in there. So we say and number of resistors, and don't forget your semicolon in here again. Hopefully I wrote it in a very good way. So so resistors, it's the same. Now what is our second step? Our second step, in fact our next step is creating an array. Creating an array actually makes things very easier for us, because it allows us to include a lot of things in a very small space. We don't have to be broad and like say int r1, int r2, int r3. It works as a list that you actually write it by yourself to include everything you will do. So how are we actually going to create an array that will store these resistor values? So we'll say float, and after saying float, we say float resistors. So float resistors, and you go in like this and you say num, because we're actually dealing with the number of resistors. So we'll say num resistors. Remember, you have to write it exactly how you wrote it in there. So we'll say num resistors in here when we are creating this float. And don't forget the semicolon in here again. And after this, let me check RE. So it has to be like this one. Do not make the mistake. So after this, now you have to create a for loop. I will explain this for loop. So when creating a for loop, you do it like this. Now you will have to declare this variable I. This variable I is actually acts as a loop counter. So you initialize it to 0 is equal to 0. Why are you actually initializing it to 0? I will explain it, but I just want to write everything in here, and I will explain it after doing everything in here. So you will say int num resistors. This is the condition, num resistors, and you write your update expression. You say I plus plus, which is I. What am I doing now? I plus plus, and do not forget your you don't have a semicolon, so you will actually go and open a bracket in here like this. I will explain everything, do not worry. You will say printf, and after saying printf, you say enter the resistance of resistors. Now we are telling the user to enter the resistance of the resistors, so you will say enter the resistance of the resistors. Remember, you have to be careful about everything you do, because one small mistake, you are out. This is very sensitive, that's all I can say. So you have to be careful about everything you do. So resistance is in ohms, so you might as well say in ohms in those brackets, just to indicate what you're actually doing, just to be more specific of what you're actually doing. So you might as well just say in ohms. And what am I doing now? I wanted to write this in here, so might as well do it like in ohms. Yes. Now and say I will explain everything. I plus 1. You will see what does that I plus 1 comes from, but as I said, I want to write everything first, and I can explain it after I've written it, because I just want you to have a clear understanding of what is actually going on in here. I don't want to just explain something that is not enough, that you won't even understand. So percentage F is actually percentage F in here, so I will just write it for you, and after that I will explain it for you. So just have patience, and you say and resistors. If I'm yes, and resistors in here, and resistors, and you don't forget this I in here. Very important, because it has a lot of contribution in what we're doing. And now you say total resistance, which is total resistance, and you say this. I will explain everything. Resistors. So yeah, and once again the semicolon, and after this you close the brackets. So let us start in here from this for int I. So from this for loop. So in here we have this int I is equal to 0. So actually this part initializes a variable I to 0. This is a variable which is this I is actually called it's a loop counter, and it will be used to keep track of how many times the loop has to run. And it starts at 0 because we usually start counting from 0 in programming, so that's why I wrote 0 in here. But if you want your own program to start at 1, you can just rub off this 0 and say 1. It's up to you, but usually in programming we'll start counting at 0, so that's why I wrote in 0 in here. And as for this part, this is a condition. This condition actually controls how long the loop will run, and the loop will keep running as long as this condition is true. And in this case, our loop will continue as long as I, which is this I, is less than the number of resistors. And once this I becomes equal or greater than the number of resistors, then the loop will stop. And for this portion, this is an update. This it's an update expression. After each iteration of the loop, this expression will increment, and meaning it will increase the value of I by 1. So if I was actually 0, it will become 1, and if I was actually 1, it will become 2, and so on and so on and so on. This part. And we have this, the loop body. So firstly we have these brackets. So these brackets is the body of the loop, and this is where the code that needs to be repeated is written. This is where everything needs to be written. And we have this printf, enter the resistance of resistors percentage d in ohms I plus 1. So let me explain to you this. As we all know, printf displays the message to the user, and in here it asks the user to enter the number of it asks the user to enter the value of resistance, for the resistor. And this percentage in d in here is a placeholder for the integer value, and this I in here is used to show which resistor starting from 1 the user is entering. So that's basically what you need to know about this line. And as for this one, it's scanf, and we know what scanf is used for. And as you can see, we have this percentage f in here. Percentage if actually tells the computer that we are actually expecting a floating point number, meaning a number that can have decimals. And we have this end resistor in here. This end resistor is the location where the input will be stored, and the I is the index, meaning that the value entered will be stored in the ith position of the resistor array. So that's basically all you need to know about this for loop right now. Hopefully you understand, but if you don't worry, we still have a lot to do, and hopefully you understand as we go. This is not the last thing we have to do in our program. Now, since from this point you now have received the value of resistors, and you know how many resistors you have. From here you know how many resistors you have, and from this for loop, which is this array for loop, now you know the value of resistors, and you know how many resistors you have, and the total resistance you now know it. So from here now we have to ask for the supply voltage. Surely the circuit has the supply voltage. Now you have to instruct the user to enter that supply voltage that the circuit has. So we say enter the voltage across the circuit. You can write whatever you want, but as long as it's actually clear it's actually clear to the user. So yeah, and you go in semicolon in here. You can say scanf to read that voltage that has been entered by the user, and you say percentage f. After saying percentage f, you go with a comma in here, and you say and voltage, and you say semicolon again. After this, you now know the value of voltage. You might as well find the current, so you say current is actually equal to voltage. We all know what current is, so you say current is equal to voltage divided by total resistance, which is total resistance. You write it like this, and you say semicolon again. And after this, you have to go to the power. You say power is equal to voltage. We know that the power, you can find the power by saying voltage multiplied by current. So you say voltage multiplied by the current. Semicolon again. Now you have to print the results. So you can say printf and say /n. /n doesn't affect anything. It's just for line spacing, and say /n again, and you go and say and do it like this, and you say printf. And after saying printf, now you can start by printing the total resistance of the circuit. You say total resistance, or print it like this, and you say the total resistance is actually in ohms, so you might as well say ohms. Like you don't have to, but you might just say ohms just to specify that this is a resistance we're talking about. /n again for line spacing, and in here you say total resistance. So total resistance. Hopefully this total resistance is right. Now you have to print again you have to print the current. You might as well just print the current and say current you do it like this. The current is in amperes, so you can say amperes, and you say comma in here, and you say current. So it will just assign it in there, and in here you say printf, and you say voltage. You have to go to the voltage now. You say voltage. I say voltage. Okay, let me write the slash n in here. I want everything to be clear, so let me write a slash n. You say voltage, and after saying voltage, you do it like this. The voltage is in volts, so you say volts. And after this, you might as well write the slash n again, and you come here and say copy, and you say voltage, and do not forget the semicolon in here again. I think you have written everything. The total resistance, the power. So you say printf now and say power. Power is in watts, so you might say just say watts slash n again, and you do it like this, and you say power. So hopefully we don't have any errors, but you will see. Now you say return 0, and you write your semicolon, and you close your brackets in here. I just hope we have no errors, but let us go build. You say comma and current 5. You say yes, and replace it. I have an error in here at this point. Let me take a look and see what my error is. In this point I have an error, so it says scanf. I did write the percentage f, I did write and say comma, I did say and say and, I say resistors. Yeah, I didn't close the brackets after this, so yeah, let us compile again. And in here I said total resistance, and I did write it, and I said resistors. I said this. What is my problem in this line? I have a problem in this line again. So you have to be very careful, guys. You have to be very careful. I think I have a problem in here too, but I can't see. I can now see what the problem is. So if you can take a look at here in this total resistance, I have wrote in like total resistance. I didn't include the A in there, so that is what is making my program not run. So let us compile again and see. So now we have no errors. As you can see, we would see that red square if we had more errors in this program. Now let us run it and see if it works as we want. It says enter the number of resistors. Let's say we have 3 resistors. I will say 3. It says enter the resistance of the resistors. The resistance of the resistors, which is the first resistor. Now I'll say the value of the first resistor is 6. It entered the resistance of the resistors 2, which is the second resistor. I will say the value of the next resistor again is 6. Now the third one, I will say it's 10. So it entered the voltage across the circuit. I will say it's 12 volts. Now as you can see, it says results. Total resistance is 22. So the current is 0.55 amperes, the voltage is 12 volts, the power is 6.55 watts. And as you can see in here, you can do it by yourself and just construct a circuit. Use 2 resistors and use the first value as 6, the second value as 6, and the third value as 10, and try to calculate the total resistance, try to calculate the current, try to calculate the voltage and the power. And if it's not the same as this one, you can leave a comment in the comment section. I will check it.